Hi, it's Akash. So we are heading towards our first this video on mathematics. So we will be playing with graphs. So first should understand what a graph is. Two axes. Basically, we need to discuss the x-axis, y-axis. This is an representation of a graph. Graph is represented this way. Now you have to understand what a graph is. I write the graph is the expression of equation. The graph is the expression of equation. So you will understand this. Our discussion will be divided into three topics, or rather three kinds of equation. One will be a zero order equation. Okay, like y is equal to c, where x has in power 0. There will be an first order equation y is equal to mx plus c. We can see we are writing it in the most commonly encountered forms. I have used m for this first order, but now we will be using, as we are more acquainted with these terms, ax square plus bx plus c. See, these are constants. A, B, C, M are constants, and I assume these are positive constants. Positive constants. They can be negative as well. So, but here these are arbitrary constants, actually arbitrary constants. So I'll rather write these are arbitrary constants, not positive but arbitrary constant. Constants. So these are arbitrary constants. So we have to learn the graphs of these three equations first of all. But we have to move from the basics. For any kind of graphs, we have to move from our basics. See, zero order extreme means x is, maximum power of x is 0. Maximum power of x is 1. Maximum power of x is 2. So two order equation. So we will be plotting these graphs. We'll know why the graph is the expression of an equation. But before it, we have to understand what is slope. What is slope? Okay, so slope is actually angle or the tan theta. I'll write the tan theta of the angle that a segment tends to to a point makes with x axis. So we'll understand this thing. What I've written, we'll just understand the thing. Let us assume this is an x-axis, this is an y-axis. We are acquainted with it. This is the origin. So 0, 0. Point O is the origin. So any curve, I hope this appears like this. Any curve, as I draw it with another ink. Any curve that appears like this. Okay, we can get a better curve. Sorry. I will drawing a curve like this. So slope, we'll be discussing about the slope. Let's talk about the slope of this small segment. See, it appears to be a point when we decrease it. It's resolution, but actually this is a segment that shows the direction at that particular small segment. Then there can be a small segment, this too, that is heading towards this. There is a small segment there heading towards this. So this angle theta, this angle, small angle theta, and this here, this angle is 0 degree. These are all the angles that they form with the x-axis, and we know that tan theta is the slope. So tan theta is the slope of this point. Tan theta is the slope for this point, and tan 0 is the slope for this point. So is 1, is 2, then is tan theta 2, then will be tan theta 1. So we can see this, that at this point slope is 0 degree, tan 0 degree actually, tan 0 degree is equal to 0. Slope is 0. Thus we can get the slope for any part. Okay, so now we'll not be discussing much about slope. It will be discussed in subsequent videos. So we'll first know how to draw the graphs for these equations. So first of all, start with zero order. Y is equal to C is the equation we need to find. It is what we are asked in the question. But we will start with our basic. We will know how the basic starts. Basic starts is y equal to 0. First of all, we will learn the graph of y equal to 0. Again, we know the graph of y equal to 0 is like this. This is the axis x and y. Okay, then the graph of y equal to 0 is actually this line. This straight line is the graph for y equal to 0. So y equal to 0 has this graph. Now y is equal to c is nothing but y is equal to 0 plus c, and c is a constant. So we have to memorize it that any positive value added to 0, added to the normal equation, which is y equal to 0, will shift the graph towards the positive side, or above positive side of y. any negative value of c added to the equation of y will deepen the graph or shift the graph downward. So this is the graph for y is equal to minus c, where c is a positive term, this length is c, and this is the graph for where it is c, y is equal to c. So we have seen the graph for y equal to c and y equal to minus c. So we started from the basic and find out the graphs for y equal to plus c as well as y equal to minus c. So our first step of zero order is complete. Now we'll find how to get the slope. So we have to remember this thing that at any point slope is equal to tan theta. Again, for any equation y as a function of fx, y is a function of x, okay, y is a function of x, we know that dy by dx, it is actually the rate of change of the function of x with respect to the x. So it is the change of y with respect to x. See, it is the change starting from here, move to there. It is the change of y with respect to the x. This is the slope. So dy by dx is nothing but a small change that we understand here, a small change in y with respect to x. See, this term is actually dx and this is dy. Are you getting it? Which one is dx and which one is dy? So this is the slope at that point. Dy by dx is nothing but the slope at that point. So we have to understand that if we differentiate the function, slope we differentiate the function, differentiate the function and put value of x at that point. Okay, so we've learned it. So we'll differentiate y equal to c. So y is equal to c is differentiated for slope. We are finding the slope for y equal to c. So dy by dx is equal to dc by dx, and we know differentiation of a constant is 0. So see, our slope is nothing but slope is 0, and you can see it. Yes, this line is having a 0 degree with x-axis. It is the x-axis, it is the line, and this is the x-axis. So this is having an angle of 0 degree. So hence it is proved this slope is 0. Okay, slope is 0. Okay, 0 degree. That's it. Now we'll move to our first order equations. So coming to the first order equation, y equal to mx plus c. We have to understand this thing from the very beginning. We'll first differentiate to find the slope. dy by dx is equal to d dx m dmx plus c by dx. So this differentiation we can easily get it is equal to m. So we found that it is the slope, right? Again, the slope is equal to tan theta. Therefore, tan theta is equal to m, right? So this is a beautiful equation we are getting. So we can represent it like this: y is equal to tan theta x plus c. This is the form. So any term written here will be representing the tan theta, that is the slope of that point. Okay, so we have to understand how can we reach to this. The equations of first order equations may not be like this. It may be like a y plus bx plus c is equal to 0. So you have to understand it is to be represented in the form y is equal to minus b by a x plus minus c by a. So it is the m, it is the c that we are discussing out. Thus this is equal to the tan theta. This one is the c. So we can now easily get such kind of things in exam and easily get the values of tan theta. Now we'll be heading towards the drawing this equation in a graph. So first we will move with the basic. Y equal to mx plus c. Y is equal to mx plus c. But we will move with the basics. We'll start with the most basic equation y equal to x and then learn how to draw this thing. So what is the graph for y equal to x? You have to understand, if it is the graph paper, y equal to x is denoting something. If this is the value x, there lies an y which is equal to x. So this is the point. So this lies somewhere there. So you can see it's an equation. It's an equation that shows a point which forms a square actually, like this. So any point x2 will be like here, for which there will be a y like there. So this is like this forming a straight line through the origin. This forms a straight line through the origin and at an angle of 45 degree with this line. We can easily appreciate this thing. It is at an angle 45 degree with this x-axis, and yes, we can prove it out actually, because here the tan theta is 1, m is equal to 1, implies tan theta is 1. So yes, theta equal to 45 degree, and this is proved also. So this is such a graph. So you have to understand that this is the graph for y equal to x. What is the graph for y is equal to mx? So see, this graph passes through the center. How can I tell? We can tell it by getting the solutions of this equation. What are the solutions of y equal to x? Solutions of an equation actually. Solution of an equation is y is equal to 0. Means means where the graph actually intersect the x-axis. This is a solution actually. This is a solution. A graph may actually move not this way, but actually move in the graph may, sorry, the graph may be moving. So then this is the solution. Even there may be some graphs like there may be some graph like this never crosses the x-axis, or a graph like this never crosses the x-axis, so their solutions are imaginary. Solutions are imaginary. Okay, so we can see this thing, y equal to c, sorry, y is equal to c. The graph for this never crosses the x-axis, so its solution is imaginary. You can see, putting y equal to 0, c is equal to 0. Putting y equal to 0, we get c equal to 0, but c is never equal to 0, so its solution is imaginary, so it never crosses the x-axis. Similarly, we can see this always crosses the x-axis, and the solution is actually like this. You get it? Putting y equal to 0, so x is also equal to 0. When we put y equal to 0, we get x is equal to 0. The solution is 0, 0. So yes, it passes through the origin. Yes, it passes through the origin. Now for y equal to mx, we can see, yes, for y equal to 0, x is equal to 0. So the solution is this, or rather the origin. So the graph will pass through the origin, it is clear. But what is the difference from this curve? Difference is this angle will be different. Angle will depend on the value of m. So we'll like to draw the graph. For y equal to mx, the graph will be like something like, see how I will be drawing it. This will be something interesting, because the graph will be like this, and we never know what is the value of this theta unless we know what tan theta equal to m is. Means theta is equal to tan inverse m. From there you can easily get the value of theta, and actually you can know the value. So this is the graph for y equal to mx. Now, as I have already discussed, that adding a positive term c, so adding a positive term c will shift the graph towards above, will shift the graphs above. So this line, which passes parallel to the previous graph y equal to mx, is the graph of y equal to mx plus c. So is it clear? Y equal to mx, now it is mx plus c. So you can draw another graph of y equal to mx minus c, which will be running just below the previous graph. So this value is c, or rather this value is c. Okay, and this angle is theta. To understand what is the value of this part and what is the value of this part, these are the solutions. See, these points actually are the solutions. Rather draw it with another color. These points are the solutions. So solutions can you find out? For y equal to 0, y equal to 0 implies mx plus c is equal to 0, implies x is equal to minus c by m. Therefore solution is minus c by m 0. This is solution. for this curve, y is equal to 0 implies x is equal to c by m. Therefore c by m 0 is the solution C. So this is the point which is 0, sorry, c by m 0. This is a positive part. See, this is positive, but this point is minus c by m 0. So hence we have got the solutions right. Okay, so we can easily get the graphs of y equal to mx plus c. So we have proved each and everything about the first order equations. So our basic things of first order equation, zero order equations are completed. We will be discussing the second order equations of x in another topic. Please like, share, subscribe and press the like button for the AKASH videos.